general circulation of the atmosphere is basically a giant heat transfer system. It circulates and distributes heat of Earth's surface through movement of air, or in other words, wind. This uneven heating causes changes of atmospheric pressure and wind blow from regions with high pressure to those with low pressure. Imagine a huge convection oven. The air is heated and will rise to the top of the oven. After this has been completed, the air will then be blown back down to the bottom of the stove by a fan, and the process continues. Similarly to the Earth's atmosphere, sunlight is the strongest near the equator, which is located in the middle. The warm air of the equator will then rise upwards and spread out north and south. After cooling, the air sinks back to the Earth's surface within the subtropical climate zone. Without the Earth's rotation, air would flow north and south directly across the temperature difference between low and high latitudes. The effect of the Coriolis force as a consequence of the Earth's rotation, however, is to cause winds to swing to their right in the northern hemisphere and to their left in the southern hemisphere. Thus, the movement of air towards the equator swings to form the northeast and southeast trade winds of tropical regions. Air flowing towards the poles form the westerlies associated with the belt of cyclonic low pressure system. In general, where air is found to descend, high pressure develops, for example, at the subtropical latitudes and again near the poles. Where air is rising, atmospheric pressure is low, as at the equator and in the mid latitudes where storms or frontal systems develop, although it is best to state that it affects wind direction but not wind speed. This cool descending air stabilizes the atmosphere, preventing much cloud formation and rainfall. Consequently, many of the world's desert climates can be found in the subtropical climate zone. Surface air from subtropical regions return towards the equator to replace the rising air, so completing the cycle of air circulation within the Hadley cell. Hadley cells provide an excellent means for describing the way in which heat is transported across the Earth by the movement of air. Other circulation cells exist in the mid-latitudes and polar regions. The general circulation serves to transport heat energy from warm equatorial regions to colder temperate and polar regions. Without such latitudinal redistribution of heat, the equator would be much hotter than it is, whilst the poles would be much colder.